Hello friends, my name is Vivek Sharma. Today we can cover this interesting problem that's called add two numbers. So this is just an extension of the earlier problem that I have explained in another video, and that was like let me go ahead and let's see that how what this problem means and what was the existing problem. So existing problem was, let's say, if we have like this, right? So earlier what we were doing in the earlier problem, 4 plus 1 5, 1 2 is 3, and 5 and 3 8. Okay, so that's how we were adding, right? Now let's say if I am having this 5 itself, apart from 3 it's 5, right? So in place of 3, if it is 5, then 5 and 5 will be 10, and it will be 0 here, and then 1 carry forward, it will be coming here, right? So this would be the this was the earlier problem that I'm explaining. Now coming back to this problem, what we are doing, this is like the second add to number second. It means this is the extension basically to the earlier problem, and here we are doing the proper addition. So when I see the proper addition, let me quickly explain that what does that mean. So if I use the eraser here, and if I quickly erase this one, right? So in this problem what I'm going to do, let's use blue color, right? So 5 and 5 10, so this will be 0, and 1 carry forward would be the 0. Carry forward will be 1 1 and 3, 2 and 1 3, and then carry forward I will be adding, so this will be 4, and 4 and 1 5. So for this will be the output for this particular problem. So what we are going to do here, we are just following the exact same rule whatever we do the addition. So if I add these two numbers, this will be the output, right? So the only difference I am trying to explain it here, we were going sequentially. So if earlier problem, if I calculate like 5 2 3 and 5 and 5 10 0, and then another node we were just adding 1. So this is add two numbers first, and this is the second that we are discussing it here, right? So did you observe the difference? And if you did not get a chance to look at the this previous problem, add two numbers, then just go ahead and look that, and then you would understand what I mean with this red color. But let's focus here on the blue color, the extension of this problem, like the current problem. So we are just adding from the last, and then we just keep accumulating our carry if it is carry. So here the carry is 1, right? 5 and 5 1, and then 1 we are adding in this, right? So 2 plus 1 3, and plus 1 equals to 4. So that's what we are doing. So of course we have to go from the last. So one way is just keep traversing till the last, and keep traversing till the last. Whatever if we find in the last element, then just what we can do, we just keep adding those elements. And in this to solve this problem, what we can do, we can just keep adding from the last and just go back. Then after adding, we need to go back to 2. So that how we can go back, there might be multiple ways, but convenient approach might be like if we take the stack and we just push all these stacks. So let's say I'm pushing 1 2 5, and 5 I already popped, and I did some operation, and then I just popped this guy, then the next element is 2, and that's how we can go to the previous, right? So this is one way. This is just in one idea that we can take the stacks, just take two stacks with the two list, and then just keep adding, right? So now this is one part of the problem. Second part is like so let's say if I added 5 and 5 0. So again, like so 0 I added here, right? This is the 0 that I added. Now I have to add another node. So this is the linked list, right? So if I have to add another node to the previous of 0 but not to the next of 0, right? So this is just an important observation here. Earlier what we were doing here, we were just 5 and then 3 and then 4 0 and then 1. We will just keep moving forward, right? So dot next, just keep adding. But here is basically we are just going backward. Backward means we are adding 0, and then we are adding 4 to the uh, ahead of 0 but not to the next of 0. Similarly, we just created this 5, but we are adding this 5 also ahead of 4, right? And that's how we are making this result linked list, right? So these are the two parts basically of this problem. One is basically just storing the stack, just keep adding. Another is just basically keep preparing our node and just keep adding ahead of the one node, right? We will understand this problem, don't worry. But let's quickly create couple of placeholders like a stack, how we will structure this problem. Once we will have the template, then we will just try to understand these this logic, right? So let's quickly do that. And it's not a rocket science, it is pretty straightforward, but I don't want to, we want to go ahead with the step by step. So let's, first step is to create the placeholder, right? So let's take two stack here, and this two stack is we can store list node itself. Stack 1 equals to new stack, and stack, let's do this. Okay, all right, so let's go ahead and fill these stacks. So if L1 is not equal to null, go ahead and stack 1 dot push L1, and L1 equals to L1 dot next. Similarly, let's do this as well. If L2 is not equal to null, then go ahead and stack 2 dot push L2, and L2 equals to L2 dot next. Alright, so now we have prepared our two stacks. So now straightforward, we can just apply the same logic if these stacks are having. So if I come back to my whiteboard, one stack would be 5 to 1, and if I take the, let's say I'm taking the green color, right, just not to confuse here. So another stack I will be like this, 4 1 5. So this will be my another stack too. So now 5 here in this stack and 5 here, they are on the top. So I'm just adding this, popping up. Similarly, after popping 2 and 1 will be the next, I will be adding those and will be popping up. After popping, I will be adding, right? So let's do the same thing here. So stack 1, if stack 1 is not empty, right? Or stack 2 dot is not empty. Why I am taking OR here, this is the important part to understand. The reason I am taking OR is because let's say my another stack is empty and I am still having the elements here. Let's say I am having 5 elements in the second list and 1 element or 2 elements in the first list, but I still want to add those as well, right? So whenever I find empty, I will just assume that they are 0, right? So that I can just have the I can have the correct calculation. But I mean the other ways to handle is just do the AND and then just get out from the loop and just store the remaining elements. But I found it little bit more intuitive, so that if I do the OR, means if it is empty, then it means basically I will just assume that they are 0, right? So let's go ahead and do that. So let's say my int a is stack 1 dot is empty. So if stack 1 is not empty, then let's go ahead and take this value not well, otherwise it's 0, right? Similarly I will do for p. So when I say stack 1 is empty, means I meant that stack 1 is not empty, right? So stack 2 is not empty. Similarly, dot is empty and I am using not, so is not empty. It would be basically is not empty but not, right? So it's not empty. And then similarly stack 2 dot pop dot well, otherwise it's 0. Now let's go ahead and add these guys. I would need carry as well. Why I would need carry? Because this is how I will just keep the carry. and carry is nothing but this would be again the sum by 10. The reason of doing that, because if we see from here 5 and 5 10, and if I divide by 10 then I will get the 1, right? And that's what I want to carry forward to the next element. In this case it is previous, right? It's not next. In the part of first problem it was next, but in this part the current problem that we are dealing with, it's we need to add to the previous element but not to the next element. All right, so let's go ahead and do that. So this is carry. Now let's go ahead and create this node. Why we are creating this node? At least we want to create our new node. So this would be sum and mod 10. Why mod 10? Because let's say 5 and 5 10, and then if we want to mod 10 then we will get the remainder 0, and that's what we want to store. Similarly 2 plus 1 3, and carry is 1 4. 4 mod by 10, then remainder itself is 4, right? So that's how this is just a typical. If you are having a trouble to understand this logic, then what I would recommend, just leave this problem, just try to add two numbers. Similarly, forget about linked list, forget about other things, just simply add the two numbers and then this logic would be clear. So this logic can be copy pasted from the add two numbers. That's it, right? Now the main logic that I was earlier talking about, that we are having this list. So for example, I created this node 0. Now I need to add another node that's called 4, but I need to add it to the basically before 0 but not next to 0, right? So to deal this problem, how I can do that, I can just take another pointer that will always point to my head, right? And what I will do, let's say I am having null initially. So let's say I'm just taking yellow color. Yellow color would be visible. Okay, that's fine. So let's say I took yellow color here, right? So let's say I created 0, and 0 I took another element that's called previous, because it will always point to the previous node. So let's say 0 dot next I will assign to the previous. So this would be initially null. And similarly I created the new node, that's 4, and similarly again, and then previous I can assign to 0. So again, then 4 dot next I can assign to previous, that's 0, and I can reassign to previous to the 4. Similarly 5 dot next I can assign to previous, and then previous I can point to the 5 itself. So my 5, that will be the result, right? Similarly I would do the same thing here. So let's say if I take this node previous equals to null, and node dot next equals to, if I do previous, and similarly previous equals to node. That's what I was explaining here, right? So node dot next equals to previous, and previous equals to new node, whatever the new node I'm creating. Similarly this current node dot next equals to previous. So now the previous, earlier I assigned to previous to 0, so this dot next will be previous means 0, and then again previous would I will be pointing to 4. Similarly what I would do, new node dot next equals to previous, so 5 dot next would be 4, and then new previous would be 5, right? So that's how I just converted that code into the code. So that's how I can do that. Now the important thing is, like carry is itself, I can either assign after this loop carry, or I can just simply add here as well. So let's say if it's still remaining the carry, then I can check, like if carry is not equal to 0, then I can still want to I still want to have the carry. If it is not equal to 0, then I want to add that carry as well. And these are the edge cases where carry is still remaining, right? Once I am done with that, I will simply return the previous, right? Let's quickly check for the compilation error, or if I miss something. So as usual, I missed something here. Cannot find symbol stack 2. Okay, so this is the typo here. Let's quickly correct that. Let's try to see other typos. So variable a is already defined in add two numbers. So okay, if it is already defined, but I need to find, it's already defined, so b. All right, let's see, this time it's worked, right? So this is the basically idea. Now if I quickly check like time complexity and space complexity. Time complexity, I would say I am just traversing both the list at the same time, right? So basically maximum I need to traverse through basically the maximum list. So for example, I am having 100 elements in one linked list and another element is having one linked list, right? But I still need to traverse till 100 elements. So basically n here, n is the maximum, wherever the maximum, right? The maximum length between two list nodes, right? So this would be my time complexity. Space complexity would still be the same, and this is also like in fact yeah, because I'm taking the stack, right? So that's why I have to maintain all these stack, right? So I'm just traversing through basically both the nodes, but the maximum, whatever the maximum I'm just getting, that's the basically the time complexity. And in fact space complexity would be m plus n, right? So m plus n equals to n. So here m plus n is why, because I'm just maintaining this both the list basically in the stack, right? That's why I say m plus n. But we calculate the approx complexity, so that's the reason it would be the linear complexity order of n, right? Anyways, let's see if it is working. So this looks like this idea is working correctly. And just a quick summary before I end this video is we need to make sure that we understood the requirement, and the requirement is just to add from the tail of the node. So if we consider the tail of the nodes, basically we need to go till the end, and the way we can go till the end of the node, basically just to maintain like some additional data structure that's called a stack here. So in the stack we will be just pushing both the nodes, and then we will have the access of the last node, and we will just keep adding those nodes, and then we will just simply apply our addition formula here. That's how we just do the addition, right? The only difference is we will be creating the new node every time, whatever the new node we will be creating, and we will maintain additional pointer that's called previous, that will always be pointing to the current row node basically, right? So initially it would be null, but every time whenever we will be just creating this node, we will be just pointing the whatever the node current node is there, we will be just assigning the previous. So whenever we will be creating the new node, every time we will be doing node dot next equals to previous, means whatever the previous node we maintained. And this way at the end, this previous will be pointing to the head of the node, and that will be our result. We will be returning that. So this is the idea. Hopefully this was useful. Thanks a lot. Bye.